Okay, welcome back. Here's video 3 on transformations. Again, hopefully we're doing okay with the translations and the reflections. Now we're going to take a look at our dilations, right? Those shrinks and stretches of our functions. So what we have here is, again, that pink box highlighted. Horizontal are still going to be inside changes. Substitutions, verticals are outside changes, which we will incorporate distribution. So a vertical stretch or a shrink, that's going to make something taller or wider. You can see that is a coefficient multiplied in front. We kind of talked about that briefly when we started investigating this whole chapter. So a stretch is something where the coefficient is greater than 1, and a shrink is where it's between 0 and 1. And these are absolute value versions of them. So I could stretch at a -5 rate because 5 is bigger than 1. The negative actually tells me that it was a reflection like we saw in the previous set of notes. Okay? And then we have our horizontal ones. Those are backwards way of thinking. The shrink is actually when the coefficient of the inside is greater than 1 because the value, the factor, is actually the reciprocal of the value. And then the stretch is 0 to 1. Now, I'm not going to harp too much on whether we know it's a stretch or a shrink right now, but we do definitely need to know whether it's a vertical or a horizontal, because verticals are going to be on the outside distributed, horizontals are going to be on the inside with substitution. Okay, so let's do, again, a few together. I'm going to take a look at numbers 2 and 3, and again, you guys will be on your own to try the rest. Again, make sure to ask questions in the class periods. So question 2, got my original function. F of x equals the absolute value of x plus 3, close it, plus 2. This is a vertical stretch by a factor of 4. Again, in blue are all my thoughts. So vertical stretch by a factor of 4. That tells me this is an outside change. It's going to be a distribution when I have to deal with it. And I know my factor is going to be of 4. That is my a value. Okay, so from here, I'm going to fill out and set up the standard format. So g of x is going to equal a times f of x for my vertical shrinks or stretches. I see that up here. Again, I know an a value. A is 4. So my whole thought process leads me to knowing that I have to take the 4 and I'm going to multiply it to the original function. So it's 4 being distributed to that original function. Again, this is the original. There is no substitution here. It is just 4 on the outside timesing it to the original function. Okay, so let's get to it. So g of x is going to equal 4 on the outside. That was my vertical stretch. And then I'm going to times it, because it's a distribution, to the original function. Okay, the original function, x plus 3 inside absolute values, plus 2. Close the parenthesis. So again, I knew it was a factor on the outside because it says vertical stretch. So that tells me I take it and I'm going to distribute. Again, that pink box up here. So here's the tricky part. A lot of kids make the same mistakes, so you're not going to be one of them. When you distribute, I cannot distribute inside a bracket. I can't distribute inside those absolute value bars. I can distribute to the front of it. I can say 4 times the quantity of that. And then I can distribute all the way back outside to the 2, but I cannot. This is like a army wall, right? It cannot be broken down. So when I write out my answer, it is simply going to be g of x equals 4 times the absolute value of x plus 3. Notice nothing changed in the absolute values, plus 8, because 4 times 2 is 8. And I am now done. Okay, so again, it is a distribution, but do not distribute inside absolute value bars. Please do not do that. Okay, and let's do one horizontal. Okay, here we go, number 3. Again, they gave me an original function. Here it is. I know that is now a horizontal stretch by a factor of 6. Okay, horizontal, inside motion, or inside change. That is going to be a substitution of the function. And I'm going to scroll back up real quick. Horizontals, the factor is the reciprocal of the value. Okay, so if they're telling me my value is 6, the reciprocal of that is when I take the value and I flip it, right? So my b value here, my factor, instead of being technically 6 over 1, I flip it and I get 1 over 6. That is going to be the number I use when I start coming up with my function. Okay, so it says g of x equals, let's make sure we get it right, g of x equals f parentheses bx. Again, I know it was an inside, it's horizontal. So g of x equals f parentheses b times x. I know b. We figured that out. b was this 1/6. Okay, so g of x equals f. And I apologize, all these equal signs look like z's. It's just a hiccup in my writing tool at home. So b, 1 over 6 times x. This is a substitution, just like we talked about in the previous problems or the previous videos. I am going to substitute 1 over 6 anywhere I see an x in the problem. Okay, so I see the x after the 3, so I know that's where I'm going to be substituting. Okay, let's get to it. So g of x equals 3. I hit the x. I'm going to substitute. I'm going to replace it with that 1 over 6x. And then I continue on with the rest of the problem. Close it, and then there's a -9 there. Then I just clean it up. What can I do? Well, I can deal with this. 3 times 1/6x gets us 3 over 6x. -9. You could technically leave it like that, but 3 over 6 is 1/2. So I'm just going to simplify that out. Okay. Again, so we are either distributing to the whole function like we saw in the first problem we did, multiply it, distribute to all the pieces that you can, can't go inside absolute values, and if it's a horizontal stretch, that is inside, substitution, replacing any x with what you came up with from your horizontal shifts. Okay, good luck with this one. Again, make sure you're asking questions along the way.